Hi, I want to spend a little bit of time today talking about the HashiCorp view on zero trust security, what it means, and what the implications of it are. I think when we talk about zero trust networking, it's helpful to almost take a step back and talk about what was the sort of traditional approach to security and what were the implications of that. And so when we talk about the existing model that you predominantly see, it's very much what I like to call sort of a castle and moat approach. You have the sort of four walls of the data center, and we bring all of our traffic over sort of the front door. This is where our ingress and egress takes place. And this becomes the single sort of choke point where we deploy everything from sort of firewalls, web application filters, SIMs, etc. So this is where all of our sort of networking gear goes. And what we do is we create this sort of binary distinction, right? Outside is bad and untrusted, inside is good and high trust. Now in a large network, we'd also segment this. So we might have some coarse-grained networks, right? This might be development, staging, production, PCI, etc. But these are still large-grained network segments. They might have thousands of nodes in each of them. Now, as we try and go to cloud, we add these nice, fluffy cloud regions in. And each of these we connect together into effectively the super network, right? The super network can be constructed from different networking technologies. Could be SD-WAN, VPN overlay, direct connect, express route, etc. It's really this concept that we're bridging it all together into one giant network. Now, I think what you often see is how do we take this perimeter-based approach and extend it to these clouds, right? And get to a point where we have sort of 100% effective perimeter here. And I think what you find very quickly is if I'm going to give you any capability in the cloud, I'm going to give you any IAM permissions, I'm giving you enough rope to hang yourself, right? And what I mean by that is I'm going to give you the right to create an S3 bucket, for example. You might define that S3 bucket and mark it as public, in which case it's on the outside of your perimeter, right? In the same way that if you just change it to private, it's on the inside of the perimeter. So what you find is in cloud, the perimeter is really a logical concept. It doesn't exist in the same way it did on-premise when you literally had four walls and a pipe coming in, right? Everything was sort of inside your premise unless you explicitly made an effort to make it publicly accessible. And so what you quickly start to realize is you really need to be comfortable making this 80% effective, right? And you can argue on exactly what that number is. If you're a pessimist, you might say it's only 50%. If you're an optimist, you might say it's a 99+% effective. As long as you pick any number that's not 100%, you break this model of the world, right? And I think this model fundamentally was flawed to begin with, right? When we said it was 100% effective, there's sort of two critical assumptions here. One is that of perfection, right? That I'm never going to make a mistake in my firewall and my web app filter. I'm never going to have an out-of-date vulnerability. I'm never going to have a 0 day that's being exploited. And so it requires a certain level of perfection that's not realistic. The second is that it never contemplates an insider threat. It doesn't matter how tall my walls are or how effective my firewall is. If I've already given you a VPN credential and you work for me and you're a malicious employee or contractor or subcontractor, right? So I think there was two critical flaws in this model to begin with. And so, in many ways, I think it's not a bad thing that as an industry, we're now moving away from it. So when we start to move towards this model where we say my perimeter is really, less than 100% effective, whatever that number is, and I consider the fact that really my adversary might be on network already, this is what brings you to fundamentally a zero trust networking model, right? And you can hear it be called different things: low trust networking, no trust networking, etc. The idea is that your core assumption is that your attacker is on your network, and so you don't trust it. It means we go away from this binary distinction of public untrusted, private trusted, right? That binary distinction kind of goes away. Yes, I still have a private network. No, I'm not making a distinction that that's a high trust environment in a way that the internet is not, right? They're all low trust, no trust, zero trust, right? So as we make this transition to sort of zero trust, our view is that there's a few different pillars of it to consider, right? So starting at zero trust, I think the next piece, the question is, well, what do we use as the unit of control? And what I mean by that is, in this world, in a traditional world, the IP was the unit of control, right? If you were within our private network CIDR or subnets, right, those were considered high trust and you were authenticated. If you're coming from the public internet, those IPs were untrusted, right? And so this might get expressed as something like a firewall control, right? The firewall is filtering, which set of subnets and which set of IPs are actually trusted, but we're managing it through a set of IPs. Versus as we move towards this sort of a zero trust setting, we don't necessarily care about the IP because again, we're moving away from this distinction. At the same time, as we go to these cloud environments, they're much more dynamic, much more ephemeral. We're spinning workloads up and down. So it's harder to manage a static set of IPs. And additionally, as we're crossing these different networking boundaries, IPs might be getting rewritten. We're going through NATs, we're going through different middleware appliances. So the IP is not a particularly portable or stable unit in that setting, right? So instead, what we want to do is hang our controls on identity. And when I talk about identity, what I really mean is it could be application identity, meaning this thing is a web server. It could be human identity and saying this is Armon. Armon is a database administrator as an example. And so we're using identity as the basis of how we're defining these controls. We would say our set of database administrators has access to our set of databases, right? That's an identity-based control versus saying IP1 can talk to IP2 as an IP-based control. So to make this work, our view is that there's 4 distinct pillars to think about, right? Pillar 1 is how do I actually think about machine identity? And so to make machine identity work, I need a strong notion of what is a web server, what is a database, what is an API, right? And here is where Vault plays. So when we think about what the role of Vault is, it's first and foremost to provide a sense of application identity, right? So when we have application identity, we can do this by integrating with all the different kind of platforms. So Vault will integrate with AWS and Google and Azure and et cetera, right? It'll also integrate with our platforms, things like Kubernetes, Pivotal Cloud Foundry, et cetera. So no matter where these applications run, we can map them in a consistent way into an identity and then define authorization rules on top of it, right? The most obvious application of this is great. Once we know that this thing is a web server and this thing is a database, is we can use that for secret management. So this is the common use case that people think about when they talk about Vault. Is great. I can use this to define, you're a web server, you get access to a database key, you get a TLS certificate, you get an API token, and Vault can broker and manage the distribution of those secrets and credentials, right? So that becomes a pretty obvious use case. The next one becomes data protection, right? So data protection, again, goes back to this model we have here, right? If we consider in this environment how we used to protect data, we used to maybe have a web server, and the users would give us, let's say, a credit card or some social security or something, and then we'd write that to our database in plain text, right? So our database would store the credit card number or the address, etc. And if we were regulated, we might use something like, an HSM device and turn on transparent disk encryption so the database is encrypting its data at rest. And so the threat model for this is really that someone knocks down the door of my data center, finds the hard disk that has customer data, pulls it out and exfiltrates it, right? What this doesn't contemplate is a network-based attack. In this scenario, if I'm an attacker and I can get to the database on the network and I can select data out from that, well, transparent disk encrypt is also transparent disk decrypt, right? The database will happily read it from disk, decrypt it, and send it out over the wire, right? So it's clear in that case that it didn't really add much from a data protection standpoint if our threat is one of network and not one of a physical breach. So in this last use case, you really think about Vault as a way of encrypting that data, right? So when that web server gets the unencrypted data, it gets the credit card number, the social security number, etc. That goes to Vault. Vault then encrypts it with a set of encryption keys that it has. It does not expose to the application. And then it hands the safe ciphertext back to the database. To the web server. And then the web server can store that data in the database. So in this case, what we're storing in the database has already either been encrypted or tokenized. So now even if an attacker can get to the database, they need a second factor attack where they're able to be authenticated against Vault, and they need to be authorized to decrypt it or detokenize that data. So really looking at, in this sort of a zero trust world, how do we think about data protection and how that evolves? It's not enough for us to just consider that our database is behind the four walls or it's behind the perimeter. We add those additional layers of you need specific authentication and authorization to decrypt that data as well, right? And so that adds an additional layer of defense. So this is where Vault sits. Then the next challenge sits way on the other side of the spectrum, right? So on the other side of the spectrum is how do you think about human identity? And this is a much more solved problem. Ultimately, this boils down to basically single sign-on as well as having a common directory. So in a previous generation, this would have been largely Active Directory on-premise serving this role. Now in a cloud world, it might be Azure AD, might be Okta, might be Ping, might be Centrify. There's a lot of different answers. But what it boils down to is I want a common directory of all my employees and maybe what groups they're in. So I know this is a set of DBAs, for example. And then the single sign-on is I need some cryptographic way to assert that identity in other systems. That might be OIDC, and I have a JOT token that's signed. It might be SAML, and I'm making an assertion about these users. So there's a number of different tools and technologies, but it kind of boils down to the same thing. I need a common directory, and I need some form of SSO, OIDC, SAML, etc., that I can consume that identity in other systems. Once I have these two pieces, I have a strong notion of who the people are that are identifying themselves and logging in, and I have a strong notion of the applications and the machines and what their identities are. Then I have the two middle workflows, right? And there's kind of, only two if we complete this matrix, right? Which is one is machine to machine, or app to app, you might call it, and the other is human to machine. And so in both of these two use cases, our challenge is how do we use the identities that we have and then use that to enforce control, right? And restrict who's allowed to talk to who. So the authentication might be coming from the identities that we already have, but then we're layering an authorization layer to make sure that only the apps that should talk to other apps do so, and only the people that talk to the apps they're supposed to. So here is where Consul fits. So Consul is HashiCorp's service networking tool. And there's really three key problems this solves, right? The first is service discovery. And so with service discovery, we start with the challenge of how do we even know what all of our applications are? Where are they? In most environments, there isn't really a catalog that says these are where all my apps are, these are all the services that I have. It's sort of an emergent property, right? There's things all over the place. So the first thing Consul solves is it gives us a consistent catalog where we can integrate it with all of our different systems, be they mainframe, VM, containerized, serverless, etc. Consul integrates with all the different platforms. And so it gives us kind of this bird's eye view of what everything is. Then on top of that, you can implement a service mesh, right? So Consul can act as the central control plane where then we can define these central routing rules, right? So we can define rules that say, great, my web server is allowed to talk to my database. My API is allowed to talk to my web, right? So that control, again, is an identity thing. We're saying web server to database is allowed. I'm talking about it at an identity level. And then how do we enforce that? Well, the way service meshes work under the hood is we're distributing a set of certificates to the different applications, right? That certificate encodes the identity, right? So the web server gets a cert that says it's a web server, the database gets a certificate that says it's a database, and it's cryptographically signed, against a certificate authority that's trusted by our different nodes, right? And then the proxies, when they communicate between one another. So when the web server talks to the database, it's going through a proxy. Similarly, the database has a proxy terminating on behalf of it. Could be Envoy, HA proxy, Nginx. The first thing those proxies do is they authenticate, is this a valid certificate that's signed? Yes or no. So now we have a strong notion of the identity on the two sides. We know it's a web server talking to a database. Then the next layer is, are they authorized? So that's when the proxy will interact with Consul as sort of that central source of truth to say, great, I'm a database, a web server is connecting to me, is that allowed, yes or no, right? And so now you can see what we're getting at is now we have an explicit control that we defined that says web server to database is allowed. We're doing it at this identity-based level. We don't talk about IP1 to IP2. And we're using this mesh-based approach to actually enforce that control, right? Now, it would be nice if all of our networks could just live in this mesh-based world, but in reality, we have existing networks. They operate in sort of an IP-centric way. We might have firewalls and gateways and WAFs already implemented. So the third piece here with Consul is what we refer to as network middleware automation or network infrastructure automation. And the challenge here is I still want to define this identity-based control that says web server talks to database, but it might be that I'm not using a service mesh. It might be that I have a firewall, I have a Palo Alto firewall as an example, in between them. So in this use case, what we would do is we would write a bit of Terraform configuration, so going as infrastructure as code, to basically say, hey, my source inputs from Consul are the set of web servers and the set of databases. And then given that, I'm going to define how should my Palo Alto firewall be configured. And so what that configuration then does, we give that to Consul. And so the moment a new web server is registered or a web server is deregistered or its health status changes, Consul will detect that, oh, this bit of Terraform code needs to be re-executed because it has a subscription or a dependency on the set of web servers or the set of databases. And so this allows us to start with that catalog of we know all the different services. As those things come and go, we can trigger automation and use Terraform to then update our firewall, our gateways, our various networking middleware devices. And as part of this network infrastructure automation, we've partnered closely with all of the major networking providers: Cisco, Juniper, A10, Checkpoint, Palo Alto. There's a longer list available on our website. And so you can see how this then enables us to operate in sort of this hybrid mode, right? Where Consul's giving us the central catalog. We can have our new greenfield applications operating in a pure service mesh, and we can have that integrated to our more traditional networking environments using network infrastructure automation, right? So it gives us kind of a holistic way of moving towards this identity-based model of handling the machine-to-machine networking, right? And then as we talk about the last use case, it's about human-to-machine, right? And this is where our newest product, Boundary, fits in. And so when we talk about human-to-machine, often there's sort of a gauntlet of steps users have to go through, right? They first have to connect to a VPN, or maybe they're going through an SSH bastion. That puts them on the private network. Because we don't want them to have access to everything, there's typically a firewall in place to restrict, great, if you're coming in from a VPN, what set of network resources are you allowed to connect to? So now you have to manage a set of firewall rules around who can connect to what, right? And then from there, if I'm connecting to, let's say, a database, I might want to do session recording, or I need to have privilege access management to restrict who has access to database passwords. So now I have to log in and use a privilege access management tool. That might be imposing session recording. And then finally, I connect to my target destination, which might be the database, right? So we looked at that and said, is there a way to simplify this where you just have a single point of entry? And that's really what Boundary is, right? So the idea is I don't have a separate set of VPN credentials, and I don't have to have a separate set of SSH keys. I do a single sign-on, right, via my IDP, right? So tie it back into this human identity we already have, and that's how I authenticate. I don't need a separate VPN or SSH credential, right? Then the second piece is I really don't want to be in the business of managing 3 different sets of overlapping controls, my VPN plus my firewall plus my PAM plus my database. I really want a logical control that says my database admins are allowed to talk to my databases, right? Again, going back to an identity-based, service-based control. And so that's how the authorization works here, right? So I have a logical sort of auth Z that operates at that service level. And that's how I specify who's allowed to do what. Right? Then the advantage is Boundary, unlike a VPN or unlike SSH, doesn't actually give you direct network access. It won't put you on the network. So I don't need a separate set of firewall controls. Boundary will only allow the user, based on their authorization, to talk directly to a target instance. And that's happening from the Boundary gateway directly to that instance. There is no private network access. And so we don't need a second level of firewall to restrict what you can do, right? So this eliminates multiple layers. I don't need to first have a VPN and SSH. I just talk directly to the Boundary gateway. I don't need another layer of firewall because I don't give you network access. And then Boundary can directly inject the credentials and in the future provide the session recording as well. So I don't need a separate layer of privilege access management either, right? I talk from a user's point of view directly to the Boundary gateway. It authenticates me, it authorizes me and connects directly to the target instance. And because it's in that middle point, it can inject the credentials as well as perform the session recording. So it simplifies that end-to-end access, right? And so it's a simple solution that then covers the sort of end-to-end use case, right? That otherwise we'd have 3 or 4 different pieces of control we'd have to interpose. So taking a zoom out, again, as we talk about zero trust, it's a much bigger space, but it really starts with this idea of, I don't want to provide any sort of a high trust assumption, right? I don't trust my network. That means everything needs to be explicitly authenticated, explicitly authorized. And so if we're going to hang everything off of identity, then the first starting points are, do I have an understanding of human identity? Do I have an understanding of my machine identity? Once I have that, I can leverage those to solve the 2 key networking flows, right? App to app or machine to machine using Consul, and human to machine using Boundary, right? So hopefully that gives you a sense of sort of how we think about zero trust and what we need in terms of the 4 pillars as we're transitioning to that. Thanks.
Awesome. Thanks so much, everybody, for joining for that. I think now we're going to switch gears a little bit into the live Q&A portion. So if you haven't had a chance, if you haven't noticed, there's sort of a little side tab where you can actually send questions in, and we have the next, at least 20 minutes or so to be able to answer those and spend some time on the questions. So I'm just going to pick them off and kind of we'll answer them as we go. There was a question just near the end here around, will this session be recorded and viewable for later? Yep, I think all of these will be recorded, and hopefully we'll get this posted up in the next week or so, and you should be able to, view it from there. So I think we'll probably email everybody who registered and get you a link to the recording. So there's another question in here around basically the example that I gave around using vault encryption of data before it goes to storage. Let's see, I mentioned that an attacker would have to get to Vault to be able to actually get to the data. So in this example, it's not clear how Vault would enforce zero trust to prevent an insider from getting cryptographic keys. Okay, yeah, so that's a good question. So I think if I talk about kind of that classic model, as I mentioned, the sort of a starting assumption was basically, hey, my database is behind the 4 walls, my web server is behind the 4 walls. So first of all, the credentials for the web server that they were using to access the database most likely hard-coded in the source code of the application, that source code being most likely pretty broadly viewable, right? Anyone who works at the organization could probably log into, whatever hosted VCS system was there and see that username and password, plus almost everybody was on the corporate network. So you have this pretty broad access in terms of almost anybody who worked at the company or anyone who could get on the network could not only find the credentials for the database that were long-lived and static and in plain text, you could connect to the database, and the data being written to the database was also in plain text, right? Now, I think the small caveat we tend to see is people often will turn on, for example, like a full disk encrypt, right? So you might have an HSM device that's plugged into your database. It's doing transparent disk encrypt or full disk encrypt, whatever you want to call it. The challenge with something like a transparent disk encrypt or a full disk encrypt is the threat model that it's protecting you against is effectively a physical attack, right? It's if I go to your data center and I pull out the hard drive, right, and I take it home, now when I plug it in and I realize, oh, the disk has been fully encrypted, or the database has been transparently encrypted, right? And so you're thwarted. But in a network-based attack, if I'm on your network and I connect to the database and say, hey, select star from customers, the problem with transparent disk encrypt is it's also transparent disk decrypt, right? So the database will happily read it up from the disk, talk to the HSM, decrypt everything, and then ship the plain text back out over the wire, right? So you're writing plain text and reading plain text. So the delta here in terms of like what Vault brings to this equation, right? So now let's take this sort of same example and say, okay, great, I have this web server, but the web server, first of all, has to retrieve the database credential from Vault, right? So it's going to go to Vault and say, give me a username and password for it. And second of all, the web server is authenticated and authorized to call encrypt, right? Let's say, so it can call encrypt with the credit card key, but that's it. So the web server now, when it comes online, gets deployed, it's going to authenticate against Vault, get the credential it needs, establish the connection. And now anytime it gets a credit card number, it talks about, it says, hey, please encrypt this credit card with the credit card key, or tokenize this for me. And then it writes that encrypted tokenized value to the database, right? So now let's take the example of a DBA. A DBA probably should have access to the database. So they might be granted that if they connect to Vault, or if they're connecting through Boundary, that they're allowed to talk to that same database. So great, they can establish a connection. But now, even if our database admin who works for us runs select star on customers, great, what they get back is a bunch of encrypted and tokenized data, right? There's no reason that that DBA should be authorized to go talk to Vault and say, have the decrypt permission or the detokenize permission for that key, right? So this is one of those ways where we're sort of starting to establish more of that kind of separation of responsibility. Just because you have access to the system doesn't mean you have access to the data, right? And then we're moving towards this sort of zero trust model of like, okay, just because you're an employee of mine doesn't mean I necessarily trust you. Now, taken to the next level, assuming I'm an attacker, I'm not the DBA. Now, as an attacker, first of all, I need to get credentials to the database, right? Those should be stored in Vault and not in plain text all over the place. And even if I can get that credential, great, I connect to the database, now I see a bunch of encrypted and tokenized data. Now I need a credential to Vault that's authorized to actually call decrypt or authorized to call detokenize. And I have to do that online. I have to stay in the network. I can't just do an exfil and data dump it and then decrypt it offline because I don't have the key. Right? So I have to stay in the network. I have to do a row by row decrypt or detokenize to be able to get that access. So it's really about dramatically elevating the complexity of that attack and then allowing us to kind of separate system access from data access. So my DBA has system access, but not data access. And then even my web server, it might only need sort of an asymmetric access. It might need to be able to encrypt the credit card key, but there's no reason it needs to decrypt it. Only my billing service, for example, needs the decrypt capability, right? So that's how we start layering this on to get towards that kind of a zero trust view, right? Great. So there was another question around sort of with this solution, what agents do you need to deploy overall? I think it depends on which of these kind of different systems you're talking about, right? So, for example, Vault, it tends to be, it's not necessarily doesn't require an agent, right? You can just run the central Vault servers and then speak directly to its APIs. We have a Vault agent that's available, but it's not mandatory. And the agent's just there to simplify some of the interaction with Vault in terms of authentication, fetching secrets, token renewal. But you can use, you can integrate with configuration management, or you can use the SDKs if you don't want to use the agent. So it's not really required. Similarly, Consul is the one that's probably most agent driven. That one does require an agent because we're doing this kind of network enforcement at the edge, and the agent does a lot of heavy lifting around certificate generation, certificate renewal, outbound connection, load balancing, inbound connection authorization. So there's a lot of heavy lift that the client does there with Consul. And then when we talk about Boundary, that's also an agentless model. So Boundary runs at sort of a gateway on the edge of the network, but it doesn't have an agent that needs to run as part of every node. So, relatively few agents are really required here. Consul is probably the most required. The other ones aren't really required. But that's a good question. Another question around here, how are we ensuring the firewall rules will be taken care of by Boundary? Yeah, that's a really good one. So, in some sense, I think, the short answer is with Boundary, you don't actually need the firewall rules. The slightly longer answer is, if we go back to why we need the firewall rules to begin with, our VPN is effectively bridging a user in and just sort of dumping them on the private network, right? So we're saying, great, someone connected to the VPN, they had a valid username and password or a valid certificate, dump them on the private network. Now, the problem is I don't want anyone who can VPN to be able to access anything on my network, right? And so the problem is the VPN really isn't session aware. It doesn't care about sort of privilege access management use cases. It's just putting you on the network. So the firewall then sits behind it to say, okay, if you're coming from this VPN subnet, what's the universe of things you can actually get to? So I'm sort of imposing an IP-based restriction now of, okay, based on this CIDR block, which I know is VPN, what all can you actually get to? And so I'm restricting what parts of my network are reachable. Now, the problem with this is at the firewall level, I can't tell, is it a web server developer who connected to the VPN and they need access to the web server? Is it a DBA and they need access to the database? Is it a business user and they need access to the BI system? So the firewall can't really tell because all it sees is IP and port. And so it has to grant access to all of that, right? So if I'm the BI user who really only needs access to the BI system, the firewall is actually going to let me still reach the web database and the web server because it can't distinguish those different clients. So Boundary sort of says, okay, this is bad. Let's kind of push that authorization to the gateway. And so what Boundary is doing is it has that strong notion of identity. So I know it's a web developer, it's a database admin, it's a BI user. And then I don't grant users access to the whole network. I'm not bridging them onto a private network and saying, now you can reach whatever you want. It's only based on those concrete authorizations that Boundary lets you then establish a connection. So my web developer, yeah, they can ask Boundary, say, connect to this web server, and Boundary will act as the proxy to that. And the web, the DBA can say, connect to this database. But the DBA can't say, connect to the BI system, right? The BI user can't say, connect to the web server. So in that sense, because Boundary is doing the authorization, and it's doing it in a way that's more fine-grained than the firewall, right? The firewall, because it lacks identity, has to give you access to a superset of services. The Boundary, because it is identity aware and sort of session aware, only has to give you access to the specific thing you're authorized for. So it's actually it's a tighter grain authorization than the firewall is able to achieve, just because it's only saying IP and port. It's not user aware, right? So in that model, you actually don't need the firewall. Now, that said, if it makes you feel better, you can still put the firewall behind Boundary and have Boundary go out through it. The problem with the firewall is, again, it's not aware, so it's going to have to give access to both the web server and the database and the BI system, because it can't tell. So in some sense, you could use it as a belt and suspenders approach, but it's not strictly required. Boundary is already more fine-grained than the firewall is. So there's another question here around, will Boundary provide temporary SSH keys in the future? Yeah, so actually I think one of the things that's on the roadmap basically for the next version of the upcoming Boundary 03 is tight integration with Vault, right? So what this will actually enable is we want to expose all of Vault's dynamic secret capability, so that instead of having a static set of credentials the Boundary is using, we can actually use a dynamic set of credentials per session. So as you're SSHing in, that could be a dynamic SSH key or a one-time PIN that Vault generates. If you're connecting to the database, that could be a dynamic database username and password that's unique to that session, right? So on and so forth. If you're RDPing in, that might be a service account that's being created just in time against Active Directory. So Vault already has this really rich capability around dynamic credentials and sort of creating these time-bounded tokens effectively. And that's sort of a perfect model to use within Boundary, where we can say, okay, every single session could actually have a unique credential that's ephemeral. And the moment the user closes that session, we can tell Vault, hey, it's okay to explicitly revoke that database key or that username and password or service account, whatever it is. And so you can have this really tight grain of, the user authenticates with Boundary. Boundary talks to Vault to generate a short-lived temporary credential. The moment the user terminates that session, we revoke the key and it's no longer valid, right? And so we can have unique, one-time, very tightly bounded credentials. And so that's going to be made possible by having kind of a tight integration between Boundary and Vault. So question on, how does authentication work with Boundary, especially when a vendor's contractors refuse to federate? Yeah, I think at the heart of how Boundary is going to work is we will support multiple IDP solutions, right? And so there's many ways to handle that. One is great. I might have a single sign-on for Okta, and that might be usable for most of my internal employees. At the same time, Boundary lets you define and manage username and password. So you might say I have a contractor who refuses to onboard onto our Okta. I can create a username and password in Boundary specific, for contractor A, or for Alice. Great, here's Alice's username and password to use against Boundary. And then when their contract's over, I can delete their username and password off of Boundary. So you can have multiple different mechanisms, right? You can have, maybe you have your own Okta, maybe you have a separate Okta that's just, separate Active Directory or whatever it is that, the contractor's using. So you can have multiple different IDPs. And if they don't have an IDP, then Vault has some basic username, and group management that you could use to say, great, this is kind of a one-off credential just for this vendor. And you can manage that separate from your IDP, which maybe most of your employees use. So it's kind of a flexibility there in terms of how you want to manage that. Let's see. So I described the kind of old world moat and the pitfalls of it, and how Zero Trust is kind of the new standard. Where is industry going from here? In 10 to 15 years, what will the new paradigms be? Yeah, that's a tough one. It's sort of a bit of the crystal ball question. I wish I could say Zero Trust was the new industry standard. I think it might be the industry standard in terms of where we're going. It's certainly not the industry standard of where we are. I think, by and large, I talk to, hundreds of customers a year. Castle and moat and perimeter is where we are. That is the standard today. So I think frankly, I think this challenge will be a 5 to 10 year challenge in terms of how folks actually adopt and onboard and really, get to the limits of zero trust. So, I think that's, at the highest level, if I think about this shift to zero trust, it's a philosophy change, it's a paradigm change, right? Or we're saying, okay, do I have this binary distinction, high trust, low trust? Not really. I'm going to throw that away, right? It's all kind of low trust or no trust, zero trust. And then it's a shift from what do I define as my control unit, IP, to identity, right? Okay, so great. I think then the downstream implications of that is, we're going to keep pushing the boundary of how do I get finer and finer grained in my zero trust philosophy. So even within that philosophy, I think there's going to be a lot of innovation over the next 10, 15 years of how do I keep shrinking that boundary sort of smaller and smaller in terms of, what's the surface area of trust, right? So I think there's kind of a lot of work ahead, even there. So I'm not too worried about sort of what's next at the moment. Do we have more detailed information about the machine-to-machine authentication use case? Yeah, I mean, I would, I would certainly recommend going to the Consul website. So just consul.io, and then if you scroll down, there's a sort of a use case box around the service mesh, and that'll go into a lot more detail. I think the high-level bits, I think the pieces that are really important is, how do we authenticate all of these services to one another? At the core of how that works is really, it's a PKI-based system, right? So every one of the services has a signed certificate, right? So the root certificate authority can be Consul. Consul can act as the CA. You can federate that out. It could be Vault, could be Venafi, could be other systems. So you have a root certificate authority, which acts as the root of trust. And then you have sort of this, each of these services, when they come up, generates a certificate signing request that ultimately gets flowed all the way up. The certificate gets signed, and these are short-lived, 24-hour, 48-hour, 72-hour certificates. So we're rotating the certs all the time. But the certificate, really all it encodes is the identity of the service, right? It says this thing is a web service, this thing is a database, and that gets encoded within the certificate itself. So what this enables now is when these nodes talk to one another, right? Web server connects to the database, we can do a very efficient authentication of the two different sides, right? We can say, great, we both have this the kind of public key of the certificate authority cached. We can validate, is this a cryptographically valid signature? So great, I know your cert is valid. The next step is I can parse your certificate and look and say, okay, encoded in your cert, I know you're a web server. Encoded in the cert on this side, I know you're a database. So that's the auth N part. Then the auth Z around what is a web server allowed to talk to? Like, who is allowed to talk to the database? The authorization rules are defined centrally in Consul, but they're effectively cached, right? So we're not kind of constantly querying Consul. We kind of define it, and then Consul distributes and caches it at the edge. So when that connection comes to the database, the first step is to authenticate the client. Are they valid at all, right? Okay, great, they're a web server. Is the web server allowed to talk to me? And then we can look at that locally cached set of authorization rules and say, cool, web servers are allowed to talk to databases, right? So at the very highest level, that's how that works. Then you can get into more fine-grained level 7 capabilities. So you might say, great, the web service, when it talks to the API service, can only call the /get-user endpoint or whatever. Again, those authorization rules are cached at the edge, right? And the authentication is then done in a sort of a distributed way because it's all baked on PKI. So at the highest level, that's really how it works, right? The auth N is done through PKI. The authorizations are defined centrally and cached in a distributed way. And then the agents and proxies that run sort of everywhere, they're doing a distributed enforcement of this. So we don't have any central bottlenecks of run every request through some central point, right? That's all done in a distributed way. But there's a lot more detail on the website. I encourage, you can go read it, and there's a lot more kind of reference guides and deep dives into it, right? Okay, so there's a question around what's the best way to integrate Consul when you have a footprint of existing environments in AWS and VPCs using a combination of Terraform and CloudFormation templates already. So can we incorporate via the stack? Yeah, so this is a great question, which is, okay, it sounds like there's a brownfield environment. What's the migration to this, right? So this is kind of a classic question. So I think there's a gradated way of getting into this, right? So I think step one is, how do we actually get all of these services registered, right, within the Consul sort of catalog, right? So step one is you need these things to be registered. So if you're already using Terraform and CloudFormation, you're in a great place because you've you've sort of automated and codified how your infrastructure gets managed, right? So step one would be, as part of that automation, you want to include the Consul agent, right? So I guess maybe a step 0 is that you stand up the Consul servers. You can either use like our managed, we now have HCP Consul on AWS, so we can manage the Consul service for you in a kind of a fully managed way, or it's a single static Go binary. You run 3-node server cluster, and it's relatively straightforward to stand up a cluster. So step 0 is sort of stand up the Consul servers, and step 1 is deploy the Consul agents into the infrastructure and start defining what those service definitions are, so that great, it knows, here's the 50 web servers, here's the 10 databases, here's the APIs, etc. So step 1 is getting these things, baked into the Terraform and CloudFormation you have, so that as they get deployed, you're registering them with Consul, and now you have this bird's eye view. And so there you can start to validate within Consul that great, are the services that I expect to be there visible, right? Is the service catalog populated? Do we have up-to-date health information? So Consul has sort of a health checking mechanism to make sure these things are actually live and not just kind of stale, dead things that are in the catalog. So step 1 is sort of that. And then I think there's the incremental onboard onto the actual service mesh. So from there, you can actually turn it on basically on a service by service basis, right? It's not an all in, all out, right? So Consul supports operating in sort of a hybrid mode where you can have, a handful of things that are mesh enabled, a handful of things that are non-mesh enabled, and then there's mechanisms we have to allow them to kind of interoperate, right? So traffic can go from non-mesh and get ingressed into mesh. Traffic can go from mesh and get terminated out to sort of the normal network. So this gives us a way to kind of incrementally onboard. So we might say, okay, let's start with our most, the things running at the edge, they have the least dependencies on them, right? It might be my web service. And I can start kind of outside in, right? Because the things at the inner heart have the most dependencies. So those are kind of the hardest to turn on all at once. So it's easy to start on the outside where you have the fewest services talking to you, mesh enable those things, define the right sort of intents of what do they need to be able to talk to, and then incrementally kind of work your way over, right? So it's not an all at one big bang, right? I think it's about step 1, get the agents deployed, make sure the catalog and the health check information is there. Then step 2 is start on sort of the outside where you have the fewest sort of dependencies and kind of work your way in towards the kind of the heart of the systems, right? The innermost services. And then use the kind of tools we have around ingress and terminating and things like that so that you can have a nice mix of greenfield and brownfield stuff, right? So yeah, I think it's super critical for us. I think the reality that we acknowledge is very, very few of our customers have the luxury of greenfield, right? Like, the reality for most enterprise customers is brownfield. So, I think we try and be super pragmatic about that of, okay, how do you onboard in a reasonable way? Because you're not going to flip a switch and go all service mesh, right? Okay, so can you talk about the number of components required to be purchased? What do we need to have in-house already? For example, AD, SSO, firewalls, IAM, etc., hardware. Yeah, that's a good question. So I'm not sure. It's hard with this interface. I can't tell who asked it to get a clarification. So I'm not sure, what components are needed to be purchased for what exactly here. Do you mean, is this specific to Consul, to Nomad, to Boundary, to the whole shebang? So maybe I'll kind of answer in a few things, which is kind of goes back to that, I think, question around like, how can you incrementally adopt this stuff? Which is, if I just wanted to start with Vault as an example, right? Really, the bare minimum is you need to run the Vault server. That's the bare minimum, right? So, if you're on-premise in hardware land, then yeah, you might need to have a box or 2 running that. If you're, a virtualized environment, you might need just a VM or 2. If you're running in cloud, again, it might just be a few VMs. We also have a managed service for Vault. So if you wanted to start there and say, I'm going to just use, HashiCorp Cloud Platform to manage it for me, that would be the bare minimum, is you just have a Vault instance that's managed. So that would be the minimum of what you would need. From there, then I think in terms of like integrating Vault into the applications, by and large, Vault's designed to integrate with what you have. So you don't need to go get something new, right? So if you're already running on Amazon, great, we'll integrate with Amazon. If you're running on Kubernetes, we'll integrate with Kubernetes. If you're running on-prem with AD, we'll integrate with AD. So generally, whatever you have should be sufficient to then go and integrate that with Vault and start using it. But you do need to have, the bare minimum, which is the Vault server has to be running. Same thing if I'm talking about Boundary. Again, it's really designed to integrate with what you have, right? So, the bare minimum is you have to run the Boundary sort of gateway and controllers, right? So, again, a few nodes running at the edge of the network, right? So might be a hardware box if you're hardware LAN, virtual VMs, might be VMs in cloud. Again, a handful of VMs there. But then it's about tying into whatever your source of identity already is, right? If you don't have an SSO provider, I would very strongly recommend getting one. I mean, I think the basis of Vault is around this idea of sort of identity-driven control. And so, as we talked about those 4 pillars, to us, a very critical pillar is human identity through an SSO provider. It doesn't really matter to us what that SSO provider is, whether that's AD or Ping or Okta. Like, we don't require any of those, but you should have one of them. Again, with Boundary, like I said, you don't need it, right? Like, you literally could manage usernames and passwords with Boundary. I think it goes kind of against the grain of what we would prescribe. Ideally, you're doing a single sign-on, and you have an IDP and managing it in a central way, but it's not strictly needed. So I think in terms of what's strictly needed is, like, for all of the products, like, you need the bare minimum infrastructure to actually run, right? Like the Vault, Boundary, Consul servers. And then they're really designed to integrate, right? So we don't require specialized hardware, or you don't have to bring other kind of solutions with it. To the extent that you have those things, it's designed to kind of integrate with them. But yeah, it's a good question. Let's see. So there's a ton of questions in here, so I might not be able to get through all of these. So we're just going to kind of pick them off as we're able to here. And so let's see. So I mentioned machine to machine, but I talked about application to application. Are they the same, or are they different use cases? Yeah, I'm kind of using that phraseology in a bit of in an interchangeable way. What I really mean by app to app or machine to machine is that's the sort of fully automated use case, right? There's no human in the loop. It's the web server connecting to the database, et cetera, right? Where, it's being done in a programmatic way, right? So yeah, apologies for the confusion. I'm just using the language in a bit of a loose way. But yeah, machine to machine, app to app, it's sort of an automated use case. Where human to machine, there's a person in the loop. And there's a slightly different set of constraints, right? Because, the people interaction might be a bit more dynamic, right? It's not like every day, at 1 p.m. I'm connecting to my database, right? Or something like that. So there's a bit more dynamicism to it, but also from a regulatory standpoint, there's a different set of controls in terms of session recording, separation of privilege, forensic trails, et cetera, where I'm not going to do full session recording on every query that my web server makes to my database. It would just be an astronomical amount of data, and there's no way I'd be able to really do much with that, right? So sort of they're different enough use cases that we sort of tease them apart in terms of, you have different characteristics, different scale, things like that. So yeah, but yeah, good question there. Question around, can Vault and Boundary be integrated? Yeah, and so I think I mentioned that kind of in passing. Then this will be a kind of a tentpole feature of the Boundary 0.3 release. We'll be having a tighter integration between them. So that's going to enable kind of secrets to be backended by Vault to expose dynamic secrets and pull in a bunch of the sort of Vault capability into Boundary. Yeah, so Boundary is still young and it's sort of maturing rapidly, but yeah, the kind of integrations that you expect will be there. Same with Consul. There'll be a Consul Boundary integration as well, so that Boundary will be able to dynamically query and say, hey, what's the host catalog, right? Armon is allowed to talk to the set of web servers. What are the set of web servers, right? Like, we can go query Consul. Consul will say, here's the 50 web servers that are registered, basically, right? Let's see. So it seems like Consul becomes the critical service orchestration point. How can we provide redundancy and scalability to Consul to avoid a single point of failure and ensure HA? Yeah, that's a really good question. So when we talk about all of these solutions, we talk about them as if they're sort of logically a single central thing. But the reality is they're all designed to be, multi-node, have kind of native notions of HA, support multi-data center, and support these sort of, complicated topologies to exactly support, high availability, disaster recovery, failover, things like that. So with Consul, for example, you never run one node of Consul. You always run a data center that has at least 3 or 5 nodes, such that it can tolerate a failure of the minority, right? So if I'm running 3 nodes, I can lose 1. If I'm running 5, I can lose 2. And so I can lose those 2 nodes, and the Consul cluster within that data center continues to operate as if nothing happened, right? So it will manage its own data replication. It will manage its own leader failover. And so it's sort of invisible to the clients that anything has happened. And then you run multiple clusters per data center, right? So data center east and data center west each have their own Consul clusters. They're talking to one another. So you can kind of query state and everything stays sort of in sync kind of seamlessly. But let's suppose I have a total outage of my east data center. West will continue operating regardless, right? So it keeps all the state that it needs and all of the information it needs to operate locally so that it can tolerate a total failure of one of the other data centers without that really being an issue, right? And so same sort of a thing when we talk about, boundary architecture and vault architecture, et cetera, is, even with, take vault, you run multiple nodes. Again, it has built-in leader election and failover. You can run multiple data centers. Each of them can kind of operate independently of one another. So these ideas around HA and DR and failover are kind of built into the architecture of how they work. So you can treat them and operate them like a logically central service. I can change a config centrally on Vault and have that replicated globally. So I treat it like a single global system, but it has those kind of bulkheads built in to make sure it operates at kind of global scale. So great question here around, do these tools work nicely in a hybrid on-prem plus cloud model? Can they be single access authorization authority across all networks and resilient through network interruptions between on-prem and cloud? Yeah, so this is a great tie into that last question, which is, yeah, absolutely, right? The way we think about on-prem versus cloud is they're just two different regions. We want to treat them differently. So if I'm running, a Vault on-prem and a Vault in cloud, if I lose the on-prem data center, the cloud one will continue to function, or vice versa. So that's kind of an important part of the design. And then, yeah, absolutely, we design all of these things with on-prem in mind, because the reality is most of our customers have a significant on-prem footprint, and will continue to do so for the next 5 to 10 years. So all of this stuff is designed with kind of a hybrid model in mind of, you might be pure cloud, you're more likely a multi-cloud, and you're most likely a cloud plus on-prem, right, customer. So yeah, it's designed to really be able to handle all of those kind of different flows. But yeah, it's a great question. Let's see, there's a question here around, do we use MFA somehow for user access on Boundary? Yeah, you can integrate, and so that's the idea, particularly with sort of the way we integrate with our IDPs, is oftentimes they allow us to then, leverage them for doing that. So take Okta as an example. You can say, hey, in addition to the username and password you're providing Okta, you also have to do the Okta push, or provide your hardware device or whatever it is, and use that as a second layer of MFA to authenticate. So yeah, there's a native notion of how do we leverage the IDPs for doing that. And then tools like Vault, for example, have native notions of MFA as well. So if you have some very sensitive operations, you're saying, great, this thing actually requires an additional MFA. We actually even go further. We have a notion of what we call control groups, where you might say, I have an operation that's so sensitive that one user alone can't authorize it, right? So I might trigger this, and then, on top of that, I actually need 2 other users to come and authorize it as well before that operation can be allowed. So you can kind of think about it as like super MFA, where each of those users may also need to say, great, I'm getting a push, or I'm using a hardware token. So you can add multiple layers of these kind of controls to all of that. Question around, how do we integrate an external CA to Vault PKI or Consul? So both of them actually have sort of notions of being able to use external CAs, right? So with Consul, there's sort of a pluggable backend interface. So you can say, great, Vault is my backend, or Venafi is my backend, or whatnot. So you can kind of configure Vault to use Consul to use a different CA authority. And then with Vault, when you're configuring the PKI backend, so actually if you go through our Learn tutorial track on this, we basically have a few different tracks where we'll say, hey, do you want to set up Vault as your certificate authority? Do you want to set up Vault as an intermediate, and there's an external certificate authority, right? And then down the road, there'll actually be modes that are more directly integrated with hardware HSM. So if you have a hardware HSM, we have HSM integration, but there's very specific kind of PKI requirements around how people might want to use that as well. So yes, the kind of answer is you can kind of configure both the systems to either act as the root authority, the intermediate authority, or really just a proxy to some external system that is the authority. Let's see, Vault, Boundary, and Consul seem like products in information security. Why is HashiCorp pushing innovation in information security when its sort of focus has been IaaS developer tools? Yeah, I mean, I think it's a really interesting question. I think for us, the way we think about it is our goal is really just to enable our customers and our users to adopt cloud and run it in sort of what we consider sort of a modern operating model, right? So we talk about our cloud operating model all the time. And I think a really key part of that is, you sort of, our view is you can't leave anybody behind. And what I mean by that is, great, if I get my development teams to cloud, or I get my operations teams to cloud, but I don't bring networking with me and I don't bring security teams with me, then I can't actually really succeed, right? Like, great, I might use Terraform and I can provision my VM in an automated way, but now to get a certificate for my web app, I have to file a ticket against my security team and wait 3 weeks, right? Because they have some manual ticket-driven process. So you're like, okay, well, then did I really succeed in end-to-end automation? Not really, right? Like, great, I saved a week on the VM spin up time, but now I'm waiting 3 weeks for a certificate, right? So, great, Vault plays a key role in that, which is now I can bring my security teams along with me. They can define those policies of how should the certificates be generated, who has database access, whatever. And now I can integrate that in a fully automated way. My VM comes up, through Terraform. It talks to Vault and says, give me my certificate, give me my database password in an automated API-driven way. And I can achieve that end-to-end automation, right? Networking is sort of the same thing. I think classic roadblock we see is great. My developer can deploy 10 times a day, but then I file a ticket to update the API gateway, or I file a ticket to update the load balancer, or I file a ticket, et cetera. And there's this manual intervention in getting the network updated for my application. And so again, I didn't really achieve end-to-end automation. I kind of got halfway there, and now I have to wait a month for someone to update the firewall. And so how do I bring those networking teams and the security teams with me, right? It's a critical piece of how do I achieve that end-to-end automation. So at the highest level, I think those are the kind of things we really care about, is like, how do I get to end-to-end automation? How do I get to sort of this developer self-service? Those things necessarily mean, there's an interaction with networking, there's an interaction with security. They have to be brought along on this journey. And so those are equally important to us, right? So I think, ultimately all of this is in service of how do I empower my developers and let them kind of self-serve and do what they need to do. But there's a reality of infrastructure and these other teams, right? Let's see. So network segmentation and routes prevent access to the whole network via VPN. Firewalling and SIEM providers provide analytics, which is part of zero trust, surely. Yeah, so I think when I talk about kind of castle and moat architectures, it's not like it's completely a giant wide open network, right? Like the reality is like we have some amount of network segmentation, we have some amount of zoning, right? So, I think we've always been able to use things like VLANs to create coarse grained networks, right? My development, my staging, my production, my PCI networks as an example. So I have these relatively coarse grained networks that I've done through network segmentation. Similarly, I'll use firewalls to do things like, great, I'm going to put a firewall on the way into my PCI zone or on the way to this particular database. But I think then if you zoom out and say, okay, but like how many nodes are in one of these fabrics? It can be thousands, right? Like we've seen environments where it's like, yeah, great, you have a production zone, but it has 10,000 machines in it, right? So it's not a particularly fine-grained network segment. Versus, I think what we're kind of saying with zero trust is your network segment, if you want to think about it that way, is of size 1, right? It's one node, right? So anytime you're going from node to node or even process to process on the same node, you're jumping through sort of an authentication and authorization boundary, right? So even if I'm 2 machines within the same network segment, right? My web server and database might be in the same segment, right? I'm still authenticating and authorizing that. I'm not just saying, well, you're in the right network segment, so it's good enough, right? And I think then the other challenge is, even though we did these network segmentations, the challenge of things like keeping firewalls up to date or keeping network segments up to date is, as we're going to these cloud environments, it's so dynamic, right? So my choice is either, okay, every time my container gets deployed onto Kubernetes, do I update the firewall to say, okay, the IP of that pod can reach the database, and then I have to deal with the fact that these containers are moving all the time, it's being scaled up and down. If a node fails, Kubernetes moves it. So I have this constant churn of firewall rules. Or what we end up seeing almost 100% of the time is you set the firewall to just whitelist the entire subnet that Kubernetes is running on. You're like, okay, whatever. It might be on any one of these 500 machines. Allow all 500 to reach the database, because I don't want to deal with the fact that this is so dynamic. So in practice, the firewall ended up being effectively allow all, right? Because you're like, I don't actually know which node the web server is running on, and I don't want to deal with it. So just allow the entire cluster to reach the database, right? So you're like, okay, well now a compromise on any one of those 500 nodes can reach the database. So how much value was I getting at the firewall level? It's better than nothing, but it's not a whole lot better, right? Versus the other way is sort of a damned if you do, damned if you don't, is if I'm getting really fine-grained with those rules, then I'm fighting the fact that it's a highly dynamic, highly elastic infrastructure, right? And things are coming and going all the time, right? So it's a great question. I don't think you want to throw the baby out with the bathwater. There's still a role for firewalls. don't get rid of the perimeter. It's a valuable line of defense. Continue to use that, right? There's still value in things like SIMs. Continue to use that, but don't treat it like the last line of defense, right? It's a good line of defense. It might be 80% effective, but it shouldn't be the last line, right? It's not the best line, right? So I think that's kind of how I think about it, is all of these techniques have a role to play, but I think we need to get more fine-grained and more segmented. Awesome. I'm being told I'm at the top of my block. I know we had a bunch of additional questions, so we'll try and get those answered and emailed out to everybody who was registered. And from here, I'm gonna hand it over for the next segment. Awesome. Thanks, everybody.